So now getting into chapter 8 about sets. Let's look at this example. It says set A is A, B, C, D, E, F. Set E is B, D, E, F, G. Set U is A, B, C, D, E, F, G, H, I, J. And you're supposed to insert either the first symbol if it is a subset or the second symbol if it's not a subset to make the statement true. So our first one here says A blank U. So the way you want to think of it is it's a subset if everything that's in the first set is also in the second set. Is everything in set A also in set U here? Yes. So you put the is a subset symbol. Next, for set E, is everything that's in set E also in set A? Nope. Because of G, G is in set E, but it's not in set A. So here we put the is not a subset symbol with that. The last one says the empty set and blank and E. What about that one? That symbol here, this stands for the empty set. It's a subset of everything, right? So when the empty set comes first, it's always a subset, no matter what set comes after it. Empty set is a set that has no elements in it. For example, let's say you're talking about politicians. You could have, say, the set of all presidents who were born before 1900, or the set of all presidents who were born in Virginia. Those would not be empty sets. But if you say the set of all female US presidents, right now, that's an empty set because we haven't had any. So an empty set is just a set with no elements in it. And an empty set technically is a subset of every set. Right. Technically, the way you look at it is it's a subset if there is no element in the first set that is not a part of the second set. And there's not an element. Don't think about it too much. Just remember that the empty set is a subset of everything.
Yes.
Just remember that.
Okay.
Yeah. Yeah.
Wait.
Mm-hmm.
One more time, so I'm trying to explain this to you. So the way I'm trying to figure this out, so there's like you have A, and so we're trying to figure out if A is a subset of U, or are we trying to figure out if U is a subset of A?
If the first one is a subset of the second one.
Read that? Like, what, like,
You would read this as, whoops,
like
right.
A given
This says A is a subset of U. That's
so
what the
U is
first one
big
says.
one, A is
Right.
the small one.
Right. You're trying to think, is everything in the first one also in the second one? So suppose we switched it around and said U and then a blank and A.
Okay. So I was trying to read it as
Right.
U is the subset of A.
So here, there's a bunch of things in set U that are not in set A. So you would do U is not a subset of A, like that. Okay. The next one is about counting subsets. And the one on your exam is set up similar to this. What's the first whole number? No, it's actually, 1's the first natural number. With whole numbers, the first one is 0. So when you're taking a look at all the whole numbers less than 10, you write them out starting with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. How many numbers are in that set? 10. Right, there's 10 different numbers in that set. So then does anybody remember how you find the number of subsets of that set? Right, so we do 2 raised to the 10th, and the answer would be 1024. So write out the set, count how many elements there are in it, and then do 2 raised to that number. Pretty short once you get used to it. A lot of these chapter 8 problems are shorter and not nearly as long as, say, that chapter 7 problem we were working on a minute ago.
Are you going to use the formula sheet?
Nope. There's really not that many formulas. Well, for example, the problem that we had a minute ago with the mortgages, I give you that formula on the exam, but other than that, there's really not that many formulas to remember. So. But remember, you are allowed to bring in 1 page of notes with one side written on whatever you want. Okay. All right, so let's look at one now where we're doing intersection, union, and complement stuff. Here we've got a universal set that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then set X is 2, 4, 6, 8, 10. Y is 6, 7, 8, 9, 10. And Z is 3, 4, 5, 6, 7. Our first problem says to find X intersect Z. What would that be in this case? What numbers are part of both X and Z? So we're looking at this set and this set, right? So 4 is in both sets, 6 is in both sets. So your answer here would be 4 and the set with 4 and 6, like that. Next we have the complement of Z. That little apostrophe, remember, means it's not in that set, but it is in the universal set. So what, in this case, what's in the universal set that's not in set Z? Correct. And then the last one is really a 2-part problem. The first thing we have to do is find the complement of Y. So what's in the universal set that's not in set Y? Right. So 1, 2, 3, 4, and 5. That's our first step. And then our second step, we find the union of that set with set X. And remember, union means you just put them together to make one big set. So we have 1, 2, 3, 4, 5, and what else?
6, 8.
Right. Putting that together with the numbers from set X, we also add in 6, 8, and 10. Any questions about those set operation problems? All right. Next, from section 8.2, we have a Venn diagram problem. So this is similar to one that was, I think, on the WAMAP assignments. And you'll have one on your exam that's in some way similar to this, but set up a little bit differently. Yes? Oh, sure. Sure. Okay. So let's go ahead and read through this one while she's writing that down. It says, the local sports radio station took a poll asking 76 listeners which teams they like to watch. And it says, 39 like the Sounders, 57 like the Seahawks, 49 like the Mariners, 32 like the Sounders and the Seahawks, 29 like the Sounders and the Mariners, 37 like the Seahawks and the Mariners, 25 like all 3 teams. So the one on your exam is going to be set up in some way similar to this in that you've got 3 sets. So we're going to draw a Venn diagram with a rectangle and 3 circles inside. So we'll have a circle here, and a circle here. And we'll label it for the Sounders, the Seahawks, and the Mariners. I've definitely found for me it's easiest to start at the end with what's in the middle and work backwards. So it says 25 like all 3 teams. So we put a 25 in the middle. So then, before that, when it says 37 like the Seahawks and the Mariners, how do we figure out what goes in this section here?
Subtract the 25 that's like all 3. So
Right.
that all goes to 12.
Right. These 2 sections together add up to 37, but we subtract 25, and it's 12. So in a similar way, when it says 29 like the Sounders and Mariners, we're looking at these 2 sections. We've already counted 25 of those. 29 minus 25, we get 4. Then 32, like the Sounders and Seahawks, that's these 2 sections here. We subtract the 25 we've already used, and we get 7 for that section. So now, when it says before that one, for example, 49 like the Mariners, what do we do to find that? To figure out what goes in this bottom section there.
49 minus 4 minus 25 minus 12.
Right, 49 minus the 3 numbers we've already got in the Mariners circle. Minus 4, minus 25, minus 12, and we get 8. In a similar way, for the Seahawks circle, we would do 57 minus 7 minus 25 minus 12, and we get 13. Then for the sounders, we do 39 minus 7 minus 25 minus 4, and we get 3 for that part. What's the last thing that we still have to do before we start answering the questions?
Do 76 minus all of those numbers to find out that 4 of them don't like any.
Right. We need to figure out what goes in the section over here on the outside. So if we do 76 minus all of those numbers that we've got in the chart here, you end up getting 4 there. So now that we've got the chart set up, let's answer the questions. How many listeners didn't like any of the 3 teams? 4, right. Next, how many listeners didn't like the Seahawks?
So it would be 8 plus 4 plus 3 plus 4. No,
Right,
yeah.
because it said we want to know who's not in the Seahawks circle. So it's 3 plus 4 plus 8 plus 4. It ends up being 19. Like that. Another way to do that, by the way, is to take 76 minus the number who like the Seahawks. 76 minus 57, you get 19. Like that. So that's another way to do that one. Okay. Then last, how many like the Seahawks and Sounders but not the Mariners?
So you do 13 plus 3 plus 7.
No, because they have to like them both. So this is the Seahawks and Sounders part right here, but not the 25 that also liked the Mariners.
Just the 7.
Right, it's just the 7 there. Does that make sense how we got that last one? Yes.
So for B,
Mhm.
why would it be 19 instead of 15?
Well, these people don't like the Sounders, these people don't like, or the Seahawks. The 4 doesn't like the Seahawks, the 8 doesn't like the Seahawks, the 4 doesn't like the Seahawks.
Okay.
Yeah. Okay. Any other questions about that one? So the Venn diagram problem on your exam will be very similar to that, just different words really, and different numbers. Yes?
We're going to have the OR option.
It's going to be similar to this one. Yeah.
So no OR.
Nope, not on that problem. No.
Okay.
All right. So then we get into some basic probability problems from section 8.3. This is one that came straight out of the book there. It says, or the A, B, and C are different than what's in the book, but the problem is coming out of the book. In deciding what color and style to paint a room, Greg has narrowed his choices to 3 colors: forest sage, evergreen whisper, and opaque emerald, and 2 styles: rag painting and color wash. Part A says, what's the probability that Greg picks a combination with color wash? So how many different styles are there? 2, right? There's 2 styles, right? Rag painting and color wash. And he's got to pick one of those, so what's the probability he picks color wash? 1 out of 2, right? Next, it says, what's the probability he chooses forest sage for his color? How many color choices does he have? Right, there's 3 colors. One of those is forest sage, so there's a 1 in 3 probability he picks forest sage, like that. Then when it says, what's the probability he chooses forest sage and color wash? This is where you take the first one and multiply it by the second one. So there's a 1/3 probability of forest sage, a 1/2 probability of color wash. So you do 1/3 times a half, and you get 1/6 through the answer. Any questions on the way that's set up? All right. Next is a type of problem. This next one is one of those that a lot of people think they understand it, but then they end up getting the problems on the exam wrong. So I want to make sure we go over one of these table probability problems. So here it says, this table shows the results of a survey that asked people if they were happy with their life. Where there's a row for people who are married, a row for people who are not married, and then a column for people who are happy or people who are not happy. So first, it says, find the probability that a person in this survey was married. How many married people are there in this survey? Right. How many total people are there in this survey?
1422.
Right, so it's 897 out of 1422. That's it. Don't change it to a decimal or reduce the fraction or anything. Just leave it like that. That's fine. So then, part B, we're finding the probability someone's happy. How many happy people are there in this table? Right. So we've got 484 out of the same total, 1422. Next, part C says we want to find the probability someone was married and happy. How many people in this table were married and happy? Right, that's where the married and happy row and column intersect. What's the bottom number? It's still 1422.
It's out of all of them.
Right, it's out of all of them. Yeah.
Not just married.
Yep. And then last part, or not last, but next, part D, it says married or happy. So when you get to the or problems, what you want to remember is you take the probability of the first one plus the probability of the second one and subtract the probability of both. And we've actually already done those on parts A, B, and C. So we take our answer from part A, 897 over 1422, plus our answer from part B, 484 out of 1422. And then we subtract our answer from part C, 375 out of 1422. So the bottom number, you'll notice, is still the same as it was before, 1422. And then if we do 897 plus 484 minus 375, we get 1006 out of 1422. Any questions on that? All right, so next we get to these given problems. So we're finding the probability on part E that someone was married given that they were happy. When you've got something that says given, that means we only look at what's given for this problem. So on part E, we're only looking at the happy column. So if you're just looking at that happy column, what's the probability that someone in that column is married? Right, 375 married people out of 484 total. Or if we look at part F where it says happy given that they're married. Since we're given that they're married, we only look at the married row. And on that row for married, what's the probability that they were happy? Right, 375 out of 897. Jeff, you're right. This is sort of a very depressing survey here, but not very many happy people in this one.
Good odds to me.
Yeah. Okay. All right. Any questions about those table probability problems for right now? Okay. All right.
41% chance I'm going to be happy with a random one. That's pretty
Yeah.
good. Better than Vegas.
I don't know. I've had amazing luck with Las Vegas and gambling, but let's not get into that. Let's not get into that here.
As soon as the class got good.
All right. So there is going to be a problem related to decks of cards on your exam, but it'll give you this picture of what's in a deck, so you don't have to worry about memorizing what's in a deck of cards. So let's look at this one as an example. It says, if two cards are drawn without replacement from an ordinary deck, find the probabilities of the given event. So part A says the first card is a spade and the second card is a spade. How many spades are there? 13. Out of how many total cards?
52.
Right. So the probability of the first one's a spade is 13 out of 52. Now we're going to multiply that by the probability that the second one's a spade.
Are you
What?
going to specify whether or not it's replacement?
Well, yeah, it says without replacement.
Okay.
Yeah. And it'll say it's going to be without replacement on your exam as well.
Okay. So, well then.
Right. We've already taken out one of the spades, so there's only 12 spades left out of 51 total. So if you multiply those, we end up with 156 out of, I think it's 2652. Let's see. Yes, 2652. So now part B, it says, find the probability the first card is not a spade and the second card is not a spade. how many of those cards are not spades? If there's 13 that are spades out of 52, how many of them are not spades? Right.
39.
Correct. So we have 39 out of 52. And then what about the second one? What would it be? Right. Again, we subtract 1 from each and we get 38 out of 51. So it's 2652 on the bottom again, and 39 times 38. Right, 1,482. And again, leave them like this. Don't reduce them or change them to decimals or anything. If you do reduce it or change it to a decimal, as long as you do it correctly, I'll count it right. But if you reduce it or change it to a decimal and make a mistake when you're doing so, I'll take points off for it. So just leave it like this. Don't do anything with it. Yes?
Are we going to go over some stuff in chapter 9?
Yeah, we'll get to that. We're just going in order. Yeah. Okay. Any questions about those card type problems? The next one actually is one from the first section of chapter 9, an expected value problem. So here it says an online gambling site offers a lottery with a first prize of $30,000. So that's the first thing you can do is win $30,000. A second prize of $15,000. So there's one prize of $15,000. And then 2 third prizes of $5,000. All right. So it says it takes $10 to enter and a winner is selected at random. What are the expected winnings if 12,000 people enter the lottery? So if we had one winner there, and 2 winners here, if you take, that's 4 winners. If you take 4 away from 12,000, you get there's 11,996 people who win nothing, right? Now, the part that a lot of times people forget is the person who gets first prize doesn't actually win $30,000. Right. You have to subtract the money they paid to enter. So they get 29,990 there. The next person, same thing. You subtract 10, and that would be 14,990. You subtract 10 from the next one, and it's 4,990. And you subtract 10 from 0, and you get negative 10 for that one. Now, what you do with each one of these is you multiply it by the probability of winning. So in this problem, what's the probability of winning the grand prize? There's one grand prize out of how many?
12,000.
12,000, right, because it says 12,000 people entered. So the first prize, the probability is 1 out of 12,000. The second prize, there's also one of those. So that one is 1 out of 12,000. The third prize, there's 2 of those. So the probability of that one is 2 out of 12,000. And then for the negative 10, as we figured out, there's 11,996 of those out of 12,000. So we're taking each value times its probability and adding them all up. 29,990 times 1 over 12,000 plus 14,990 times 1 over 12,000 plus 49,90 times 2 over 12,000 minus 10 times 11,996 divided by 12,000. And here we end up with negative 5.42, just to round it off to 2 places for dollars and cents. And that's it. So the expected winnings is that you would lose $5.42 on the average for this game. Does that make sense how we work through one of those, setting up the values and everything? Okay. So that's an example of the type of problem you'll have from section 9.1 on the exam.
Question. So
Yes?
we have to write an answer subtracting the 5.42 because the question is what are the expected winnings?
And the expected winnings is that you would lose 542 because it's negative 542. Right.
Oh,
So that is the final answer for that one. Yeah.
Better odds and straight.
All right. So next we get to some counting problems from section 9.2. This is really hard to review these because there's a lot of different types. Make sure you look at those examples 53 through 68 from page 484. Basically, I picked 2 of those and put them on the exam. Yes?
There's a thing from 9.1 that
Mhm.
you read over that I couldn't find in the notes. It was problem number like 5 and I think 6 from the homework assignment. It had to do with finding the expected value of the insurance policy, but then it had like the percentages of having an accident, and I didn't understand.
That's very similar to what we just did there. Hold on a second. So you want to make sure when you're looking at the counting problems from section 9.2, you want to make sure you know if it's a permutation problem or a combination problem. So remember, permutation problem means that order makes a difference, so that things are being picked in a particular order or for particular positions. Combination means that order or position does not matter. So let's say there's 40 members of the math club at a college, and you want to figure out how many different ways they can choose 3 members for a party committee. We've got 40 people, they're choosing 3 of them. When you're choosing people for a committee, does order make a difference? Does a committee of Bart, Kate, and Courtney, is that different than Courtney, Kate, and Bart? No, it's the same. So this is a combination problem because the order does not make a difference. And then you can use the formulas if you feel like it. It's a lot easier if you just remember the calculator steps for calculating these combination problems. And you get up here 9,880 for the answer. The next one says, in how many different ways could they choose a president, vice president, and treasurer? You've still got 40 people. You're still choosing 3 of them. Does order make a difference this time? Yeah, because having Bart president and Kate vice president is different than having Kate president and Bart vice president. So this is a permutation problem. So we have 40 P3, and we get 59,280. Like that. Let's look at number 19. It says, an athletic advisory group at a college has 12 faculty members and 8 coaches. In how many ways could they choose 3 faculty and 4 coaches to go to a national conference? So is this going to be a permutation problem or a combination problem? It's a combination because they're not being picked in any particular order. They're not being picked first, second, third, fourth, anything like that. So it's a combination problem. So this is really 2 separate problems. You're going to take the number of ways you could choose 3 faculty and multiply that by the number of ways you could choose 4 coaches. How do we find the number of ways you could choose 3 faculty for this problem?
12C3.
Right. We're doing the number of combinations of choosing 3 from 12. So 12C3. Then we multiply that by the number of ways you could choose 4 out of 8 coaches, which is 8C4. So if we do 12C3 times 8C4, we get 15,400. Like that. Any questions on the steps or the calculation part of that? All right. So